All right, pre-calculus, welcome to your notes video. No matter what type of day we have on Friday the 23rd, this is your notes video. You guys should have this in your possession. If not, I'm gonna write this on a separate sheet of paper, all right? This was handed out on Thursday. All right, so it says graph y equals 3 cosine x plus pi minus 1. Name, make sure your name's on it. I'm going to receive this from you. All right, so remember, with sine and cosine, these are always going to be the same. Our cardinal angles are 0, pi over 2 pi, 3 pi over 2 or 2 pi. Cosine of 0 is 1, followed by 0, negative 1 cosine pi, 0, and cosine of 2 pi is also 1. So if you have any cosine graph, these two columns will always be the same. And getting the y value should be pretty easy. I'm going to do 3 times this minus 1. 3 times this minus 1. 3 times that minus 1. 3 times that minus 1. 3 times that minus 1. Notice you have the same values twice. All right, that's the y value. Yay! And then to find the x value, remember the majority of the points are coming from this table. You simply take this angle and set it equal to those cardinal angles. So x plus pi, you set it equal to 0, you get negative pi. Do it one more time, and only one more time is needed. You're going to say x plus pi is equal to pi over 2, which I did over here, and you're going to get x plus pi equals pi over 2. You're going to subtract and get negative pi over 2. So I'm going up by half of a pi. All right, yeah, okay, that was a big brain fart. Negative pi to pi is 2 pi, which the period is. It's 2 pi divided by 1. All right, struggle there for a second. You guys always graph these two columns. That's your x, that's your y. So my first point is, and I just went by 2's here. This is my graph. My first point is negative pi 2, negative pi over 2, negative 1, 0, negative 4, pi over 2, negative 1, and pi 2. All right, remember with the cosine graph, it hits that point, immediately goes down. Hits that point, immediately goes down, because these are max values. If you were to do like, I would have to take off for this, guys. Okay, if you did that, like you clearly went above it, I would have to take off for that. So hit that point and go south. I mean, even if you did something like that, I'd have to take off for it, okay? Hits that point and goes south immediately. All right, you guys need to pause this whenever. I'm making this at lunch on the 22nd. All right, that's why we're down a sponsor, though. Shout out to all the gluten-free brown rice and quinoa pasta and their turkey burgers. Their turkey, ground turkey, of which you make into third-pound burgers. Body of the temple. Y is equal to negative 2 sine of 2x plus pi plus 2. Again, so how you set up the table, because the table is going to be given to you, and I didn't really explain that well in the last one, sorry about that. It's always x. X is always the first column, and then y equals the whole thing is always the last column, okay? So it goes x, and then followed by the angle. The angle is next. And then, so again, x, then the whole angle, and then sine of the whole angle, and then the whole thing. So we're kind of building it out from here. X, the whole angle, sine of the whole angle, and then the whole thing. You see that? All right, so again, 0, pi over 2 pi, 3 pi over 2, 2 pi. Sine of 0, again, sine of 0, because that's what 2x plus pi is set equal to. Sine of 0 is 0. Sine of pi over 2 is 1. Sine of pi is 0. Sine of 3 pi over 2 is a negative 1. And sine of 2 pi is 0. Again, I'm getting these 0, pi over 2, pi, 3 pi over 2, 2 pi. So I'm really looking at the x and the y-axis when I graph it, when I pick those cardinal values. All right, I'm going to take all of these numbers and multiply by negative 2 and add 2. Multiply by negative 2 and add 2. Multiply by negative 2 and add 2. Don't really need to do it again. Multiply by negative 2 and add 2. If that's 0, 2, then this is 0, 2. All right, I'm going to set 2x plus pi equal to 0. So 2x is equal to a negative pi over 2. I'm going to set 2x plus pi equal to pi over 2. So I'm going to get 2x is equal to negative pi over 2. I'm going to divide by 2 to get negative pi fourths. All right, so I'm adding a quarter of a pi each time. Also, negative pi over 2 to pi over 2 is pi. 2 pi divided by 2 is pi. So I know the period has to be pi. Okay, I'm going to graph these points. Negative pi over 2, 2. I'm going by 2's again. Negative pi fourths, 0. 0, 2. Pi fourths, 4. Pi over 2, 2. Now a sign does go in opposite directions. All right. And just you'd be wrong. You'd only be wrong if like you did this and continued forever, because that is the low and that is the high. Like if you went all the way up like that, I would have to count. I would have to count it wrong. Like not totally wrong. I'd have to take off. Okay, so just draw a little tiny arrow showing that it's gonna go down for a little bit. It's gonna go this way for a little bit. Just don't continue it that far up. All right, and folks, we are rolling. Okay, next one, graph y equals 3 sine x plus pi over 2 minus 2. In 0 to 2 pi, 0, 1, 0, negative 1, 0. I'm going to take all of these values here. I'm going to triple them and subtract 2. All of those values to get these y values. You just simply take these numbers and triple and subtract 2. Triple and subtract 2. All right, those are the y values that I'm graphing. Then I'm going to set x plus pi over 2 equal to 0. X plus pi over 2 equal to pi over 2. I get these two values. I'm going up by half of a pi each time. Negative pi over 2 to 3 pi over 2 is 2 pi, which is the period because it's 2 pi divided by 1. Oh, no. I didn't graph it. Well, let's graph it together. I'm going to go by 2's. So that's negative pi over 2, negative pi over 2, negative 2. Then I'm going to have 0, 1, 0, 1. Then I'm going to have pi over 2, negative 2. All right, then I'm going to have pi, negative 5, goodness. So negative 3, negative 4, negative 5. Right there. Then I'm going to have 3 pi over 2, negative 2. All right, so it's going to go like that, just a little bit. I'm going to go like that. Nice. All right, nice graph. And rolling we go. Y is equal to negative 2 cosine, and I didn't graph this one either, so we'll graph this one together. And then, the rest of it you guys can read. 0 to 2 pi, 1. Cosine of 0 is 1. Cosine of pi over 2, cosine of pi, cosine of 3 pi over 2, cosine of 2 pi. I'm going to take all of these numbers, multiply them by negative 2, and add 3. Multiply by negative 2, add 3. Multiply by negative 2, add 3. Multiply by negative 2, add 3. All right? Nice. Then I'm going to take 2x minus pi over 2 and set it equal to 0. I get 2x is equal to pi over 2. If I take half of a half, I have a quarter. Next, all right. Next, I'm going to take 2x minus pi over 2, set it equal to pi over 2. I'm actually adding pi over 2, so I'm going to get 2x is equal to pi, and I'm going to get pi over 2. So I'm going up by a quarter of a pi. Because if I have 1 quarter and I need 5 quarters, that's 4 quarters, which is 1. Again, 2 pi divided by 2. All right, I'm going to graph this right here. So my x's, those are my y's. So I'm just going to keep going by 2's. Everything is on the positive side here. So positive pi fourths, half, 3 pi fourths, pi, 5 pi fourths, 1, 2, 3, 4, 5. Again, shout out to the great Dr. Greg Budsman. All right, the Budsman method here. Should one day you see this video, be among the 87 people that watch it. I would be honored. All right, pi fourths 1, pi fourths 1. Pi over 2, 3. 3 pi fourths 5. Pi 3. 5 pi fourths pi. Again, normally cosine starts at the top, has a midlife crisis, and comes back up. This one starts at the bottom, achieves greatness, and then loses it all. That's a sad story. Then again, it bounces off and comes immediately up because that is the lowest point. That is the lowest point. All right. Again, pause this whenever you need because I got to keep going. Lunch is only so long. All right, why? Now we got tangent. Again, guys, with tangent, because tangent is sine over cosine, we're going to have some asymptotes here. We always go from negative pi over 2 to pi over 2. Negative pi over 2 to pi over 2. All right. Just kind of, yeah, we're just going to do that. Right? Negative pi over 2 to pi over 2. Going to look, when we talk about tan inverse, taking on values in the fourth and first quadrant later, then this will just go with it very well. All right, so negative pi over 2 to pi over 2. Now, negative pi over 2 is the same spot as 3 pi over 2. It's way down south where sine is 1 and cosine is 0. And tangent is sine over cosine. So tangent of 3 pi over 2 or negative pi over 2 is undefined. So negative pi over 2, and it's going to be undefined, then followed by undefined. That's pretty easy. Then we go around by quarters because tangent of negative pi fourths in the pi fourths family, cosine and sine are either the same or opposites. So tangent's going to be plus or minus 1. 7 pi 4 fourths, cosine is positive, sine is negative, so that's why it's a negative 1. I'm going to do 3 times negative 1 minus 1. Tangent of 0, sine of 0 of cosine 0, 0 1, which is 0. 0 times 3 minus 1. Tangent of pi over 4, cosine and sine are the exact same, so you get 1. 3 times 1 minus 1. And then tangent of pi over 2, again, sine is 1, cosine is 0. Here, sine is a negative. If I said sine is 1, I meant sine is negative 1. Anyway, still negative 1 over 0, undefined. Sine of pi over 2 is 1. 1 over 0, undefined, so then undefined. So these are my vertical asymptotes that are going to bound it. Okay? Then I'm going to set x minus pi over 4 equal to negative pi over 2. I'm going to add a quarter pi to negative half of a pi, and I'm going to get that. I'm going to set negative pi over 4 equal to negative pi over 4, so I'm 0. I get 0, so I'm adding a quarter pi each time. Negative pi fourths to 3 pi fourths. If you don't do anything to tangent, like there's no value here, then it's going to have a period of pi. All right, it's going to have a period of pi. And it's not going to be 2 pi. So again, I graph these. All right, so negative pi fourths. And that's what I'm going to go by 2. Negative pi fourths, 0, pi fourths, pi over 2, 3 pi fourths. And look at that. Vertical asymptotes here, vertical asymptote. Nice. 1, 2, 3, 4. All right. All right. 1, 2. All right. So I always do a poor job with graphing this and then putting this on the interwebs. I want to be careful here because we're missing a few points. You know, we're not graphing tangent of negative pi 6 or negative pi thirds. So what we're going to do is just kind of go like that with it to approximate it, okay? Not the that would be a better graph, honestly. It just hugs it, and then boom. Okay. Anyway, do your best there. And then, let's chat. Negative 2 tangent, 2x plus pi plus 1. Again, negative pi over 2, negative pi over 4, 0, pi over 4, pi over 2. Undefined, undefined. Tangent of negative pi fourths is negative 1. Tangent of 0 is 0. Tangent of pi fourths is 1. Radian mode. Undefined, undefined. I'm going to take negative 1, multiply it by negative 2, and add 1. Take 0, multiply it by negative 2, and add 1. Take 1, multiply it by negative 2, add 1. All right, those are my y values, or my vertical asymptotes, which I got to find at what x location is it. I'm going to take 2x plus pi, set it equal to negative pi over 2. So if I subtract pi from both sides, I get 2x is equal to a negative 3 pi over 2. If I divide it by 2, I get negative 3 pi fourths. I'm going to set 2x plus pi equal to negative pi fourths. I'm going to get 2x is equal to negative 5 pi fourths. I divide by 2. All right, I'm going to add, it might be hard to see, but I'm going up by eighths. This is negative 6 over 8 to negative 5 over 8, negative 4 over 8, negative 3 over 8, negative 2 over 8. And that's how it simplifies. All right. I recommend that. Get them like Get the denominators the same. Okay, everything is on the left side. So negative pi fourths, negative 3 pi eighths, negative pi halves, negative pi 5 pi eighths, negative 5 pi fourths. Everything is negative. So my vertical asymptotes. Negative 5 pi eighths, positive 3, 1, 2, 3. Followed by 1. Followed by negative 1. All right, that's a little better. Still not perfect. Not perfect. All right, folks. So here we are. We should be honestly pretty good knowing how to do these. So if I just briefly say, hey, here are some answers, and then ask for you to maybe finish the last 2 on your own. Mr. Yak, no way. So again, I take the absolute value of this. The amplitude is 4. The period is 2 pi divided by that number right there. What's attached to x? 2 pi divided by 2 is pi. The phase shift I set to this angle equal to 0. 2x minus pi thirds is equal to 0. I get pi over 6. The range for any sine is always negative 1 to 1. First I multiply it by its amplitude. Now it's negative 4 to 4. And then this little vertical shift, I subtract 1 from the lower bound and from the upper bound. Now I'm looking at negative 5 to 3. All right, so I'm definitely going to give you the answers here for 7, 8, 9, 10. Probably going to have you finish 11 and 12. This is due at the end of the hour if you have a sub on Friday the 23rd. And if not, then this is due on Monday. All right. Or, Tuesday if Monday has bad weather. We shall see. We're at that time of the year, folks. The amplitude is the absolute value of negative 2, which is 2. Period, 2 pi divided by 3, which is just 2 pi divided by 3. The phase shift, I set 3x plus pi equal to 0. The range, negative 1 to 1. I'm going to multiply it by the amplitude, which is 2. I'm going to add 1 to the lower and upper bound, negative 1 to 3. Negative 1 to 3. All right, folks, here we are, number 9. The amplitude is the absolute value of negative 5, which is 5. The period is 2 pi divided by 4, which is pi over 2. The phase shift, I set 4x plus pi equal to 0. And you can say pi fourths to the left, but negative pi over 4 is fine. We take the amplitude, which is 5. My range was negative 1 to 1 with a generic function. I'm going to multiply it by 5. Then I'm going to subtract 2 from the lower and upper bound, negative 7 to 3. Item number 10, the amplitude is the absolute value of 3. The period is 2 pi divided by 2. Phase shift, I'm going to set 2x plus pi fourths equal to 0. Probably won't have one harder than this. I'm going to move that over, and I'm going to double the denominator. The range is negative 1 to 1. I'm going to multiply it by 3 and subtract 4. Negative 7 to 1. All right, folks. I believe you can do 11 and 12. Again, the email will also clarify when this is due. Again, if this is an e-learning day, I'll have this on Monday. Turn it in, top tray. Easy points. If you have a sub on the 23rd and you have learning in class, in person, then you're going to turn this into my top tray by the end of the hour. I've noted that anything turned in later today needs to be marked late. This is Yak Math Videos, signing out.